Ahiahi Marie, good afternoon everyone and welcome to today's CPD webinar brought to you by Rinnai, New Zealand. I'm Alice Wu, National Specification Manager from Rinnai, your host and moderator. Thank you for taking the time to join us today as we talk about the fundamentals of residential water heating solutions. Now, while we're waiting for everyone to arrive into the room, let's test our chat function by typing the type of water heaters we have at our own homes. Again, please tell us by typing in chat the type of water heaters you have at your own homes, whether it's gas continuous, hot water cylinder, hot water heat pump, or electric continuous. Please let us know. Thanks, Nicola, and thanks, Craig. Oh, great to see all the answers rolling in. That means our chat's working. I think it's a mix of electric storage and gas infinities. We'll just give people more time to get in. And where is everyone dialing in from today? Oh, Thomas, like your answer? Thanks, Mike. All right, well, thanks everyone for all your answers and good to know that chat is working. Let's start. So welcome to today's CPD webinar brought to you by Rinnai, New Zealand. I'm Alice, National Specification Manager from Rinnai, your host and moderator. Thank you for taking the time to join us today as we talk about fundamentals of residential water heating solutions. This webinar aims to assist architects and specifiers to gain a better understanding on the different water heating options for you and your clients. Today's format will be 40 minutes of presentation followed by Q&A with 10 NZRAB CPD points. For smooth running of the presentation, we kindly ask you to submit your questions in the Q&A section and we'll answer them during Q&A time. So again, please type your questions in the Q&A section and we'll answer them during Q&A time. Now, if you've joined us via the Teams web format and don't have some of the functionalities or simply too shy to ask questions publicly, don't worry, we will have our contact details at the end for you to send questions through privately. So let's start with a 1-minute introduction about Rinnai. Rinnai has been in New Zealand for over 45 years and is located in Auckland. With over 1 million appliances installed into Kiwi homes and businesses, Rinnai New Zealand has established a proud reputation for quality and reliability. Rinnai's mission is creating a sustainable, healthy and comfortable way of living. We provide a range of products and services that covers climate control and water heating solutions, and we're the expert in total home living. For water heating, Rinnai has gas infinities, hot water cylinders, hot water heat pump, and commercial solutions. For climate control, we have heat pumps, gas central heating, gas fireplaces, electric fireplaces, and warming tin wood burners. Now, without further ado, it is my pleasure to introduce our speaker for today, Dr. Grant Burke. Grant has almost 40 years of experience in water heating and graduated from the University of Auckland with PhD in mechanical engineering. He has lectured in building services at AUT University and assists Rinnai with water heating specification, installation design, and fault finding from residential through to large commercial buildings. Over to you, Grant.
Thank you, Alice. I hope everyone can hear me okay. So we're going to look at a few different types of water heaters this afternoon. We're going to look at a standard electric cylinder. We'll have a bit of a look at electric heat pumps, gas continuous flow, of course, electric continuous flow. Solar PV, we won't look at specifically. We mostly use simple electric storage water heaters for solar PV applications. Solar thermal, we're not going to look at. We have product for solar thermal, but it's a very, very small market in New Zealand, and it's a very specialist market. So we don't have time to go into the ins and outs of solar thermal today. So if we have a look at a standard electric hot water system, we've got here a Rinnai indoor-outdoor cylinder with a nice colour steel jacket. Can be installed inside or outside your home. And we have a look at a standard plumbing system that would go with that water heater. So we have a mixing valve that'll stop the water coming out of your taps being so hot that it will scald people. We've obviously got a shower mixer here, and we've got someone waiting in the shower to have a nice warm shower. So we have cold water supplied in the bottom of the tank. Hot water comes out of the top of the tank. At the mixing valve, we mix some cold water with the hot, so we get water coming out of that at a safe temperature, that were that water temperature to get on us in the shower, we'd be able to jump out of the way quick enough that we wouldn't get badly scalded. At our shower mixer, of course, we mix some cold with that hot water, and then we have a nice toasty shower. Let's say in this application we've got cold water coming in at 10 degrees, which is a bit colder than it would be in Auckland at this time of year, but might be Wellington, might be something like that cold water temperature. And we've turned the thermostat on our electric storage tank to 65. So we have 65-degree water come out of the top of the tank. The mixing valve mixes it to 50 degrees. I'll talk about that in a bit more detail in a minute. At the shower mixer, we mix the water down to 40 degrees C or thereabouts, slightly cooler than that for having a shower. Now, this 50 degrees is something I'd like to touch on. 50 degrees is the requirement as of the 2nd of November this year. It's in the acceptable solution already, but there's a year transition allowed. So currently we're mostly working at 55 degrees, but by the end of the year, buildings consented after that date, the water will need to be limited to 50 degrees. That limit only applies to what's termed sanitary fixtures for personal hygiene, so mostly showers and vanities. It doesn't apply to kitchens or laundries. So normally what you do is you take that same mixed water at what was 55 degrees and take that to your kitchen and laundry. This water temperature change to 50 degrees was made 15 years ago or so in Australia, and the experience there was that many customers didn't find that 50 degrees was hot enough at their kitchen sink. And there were some complaints from customers about the water temperature they had available in the kitchen. So there's some things we can do with a electric storage water heater installation to get a bit hotter water to the kitchen sink. So what we see here is a Rinnai Reheat product. It comes with all the valves and the pipes out of the carton as you see it. Generally, we sell these for multi-unit residential applications. So same plumbing system on the side of the shower. The mixing valve is already part of the cylinder piping. You'll notice at the hot outlet, it might be hard to see, there's a little brass plug in the fitting there, and that plug can be removed and you can take straight hot water into your kitchen and laundry. Remembering that that hot water will be at the temperature that you've set the tank to. In this case, it would be 65 degrees. The customer, if they're getting short of hot water, can of course turn up the thermostat in their water heater, and they can turn it up to about 75. And 75-degree water might be just a bit too dangerous to go into your kitchen and laundry. So worst case, you may need to install a second mixing valve to the kitchen and laundry set to a temperature that's a bit hotter. So if we look at the same thing with a gas continuous flow system, it's slightly simpler. Cold water enters the gas continuous flow. The gas continuous flow is set to, in the past, 55 degrees, but from now will be set to 50 degrees. You mix some cold water at the shower mixer, and you have your 40-degree water come out of the shower head. So we've got the Infinity set to 50. The Infinity is tested and certified to act as a mixing valve, so it won't produce water hotter than what it's been set to. So again, similar issue. What happens if 50 degrees isn't hot enough at my kitchen sink? So we need a slightly different plumbing arrangement. We have cold coming in. We might now set the Infinity to 60 or to 65 degrees. So coming out of the Infinity will be 60 or 65 degrees. We take that to our kitchen or laundry. For the shower and the vanities, we need to mix some cold water. And so we get 40-degree water coming out the other side. So with this, I guess what we're flagging here is that with this change to a 50-degree temperature limit in showers, baths, and basins, the plumbing may get slightly more complicated in your clients' homes if they want water hotter than 50 degrees at their kitchen sinks. So obviously in doing that, we now have the mixing valve installed under the Infinity along with some other valves and pipe connections, and that looks a bit messy. It's often on the outside of your house, and I don't like the white color anyway because it doesn't match my house. So we'll put a graphite Rinnai Infinity in, and we'll fit an optional pipe cover to the bottom of that, and so that'll hide all those pipe fittings underneath and make a nice tidy installation. So that's our gas continuous flow. If we go back now to the storage water heater for a moment, I'm using water in my shower at 40 degrees. I've got the water in the tank at 65. So as I use that water and mix cold with it, how much hot water am I actually drawing out of the cylinder, and how long is it going to last? So my standard shower would be 8 litres a minute, fairly typical shower. If I'm in the shower for 10 minutes, I'll be using 80 litres of mixed water at 40 degrees. Obviously, I'm going to be using a bit less than that of neat hot water out of the cylinder. So what do I need to know in order to calculate how much water I've actually taken out of the cylinder? I need to know the temperature difference between the cold water and the temperature that I'm using the water at. So in this case, I'm using it at 40. I've got 10 coming in, so I've got a 30-degree temperature rise that I'm using the water at. And I need to know the temperature difference between what I've stored the water at and what it's coming in. So in this case, it's 55 degrees. So I then multiply my mixed water use by the temperature of rise that I've used the water at, divided by the temperature of rise that I've stored the water at. And so I've used 44 litres of hot water out of that storage tank. If I go somewhere colder, I've used 47 litres of hot water out of the storage tank. If I go somewhere warmer, such as Auckland in the middle of winter, I've used about 40 litres of hot water out of the storage tank. So this is the number that we need to calculate when we're trying to decide how big a cylinder to specify into somebody's house. On the left is sort of a schematic representation of a hot water cylinder, and I've got the shower on, I've got cold water flowing into the bottom, and I've got hot water being drawn out of the top of the cylinder. As cold goes in the bottom, it mostly stays in layers, but we have a bit of a mixed layer between the fully hot water and the cold water in the bottom of the cylinder. As we draw more and more water out of the cylinder, that mixed layer moves up, and I suspect most of us have had that sinking feeling when we're in the shower and we feel the water temperature start to drop, and we know it's time to rinse off and get out of the shower because the water's going to be fully cold soon. And what happens with most electric storage cylinders is you get about 90% of its volume out of it before the water starts to run lukewarm. So we need to keep that in mind when we're sizing a cylinder. So if I'm in Auckland, from the previous slide, we've got 4 people in the house. We're going to let them have a 10-minute shower each. So we've got 4 lots of 40 litres of hot water used out of the storage cylinder, which means I need 160 litres of fully hot water in order to provide that many showers. 160 litres divided by the 90% for what I'm going to get out of the tank before it runs lukewarm comes to 178 litres. So that means we need a 180 litre storage cylinder. And so that's really where we come to that number, where a standard 3-bedroom house had a 180 litre storage cylinder, 3-bedroom house, 4 occupants, 180 litre cylinder required. So you can run through those numbers for houses with more occupants and more bedrooms. So when we're looking to specify an electric storage cylinder, we really want to know how many people are showering. And the other thing we need to know is, are there lots of baths, and are they spa baths, and are they big spa baths? And are they used regularly? That can obviously use an awful lot of hot water really quickly. So if there are large baths and they're used a lot, we need to make an allowance for that and increase the size of the cylinder that we're specifying. So that's how much hot water we need to get the job done. The second factor we need to think about when we're looking at electric storage cylinders is the length of time it takes to reheat the water once we've used all the water in the cylinder. And that's related to how big or how powerful the electric elements are that we have in the cylinders. We need to be mindful of how much electricity capacity we have available in our homes. So at my place, a standard standalone home, if I look on my electrical fuse box, I see that my main fuse is 65 amps, and that's completely standard in a New Zealand home. You can uprate that at a cost. So if I have a 2 kilowatt element, which was really traditional, I'm using up 9 of my available 65 amps of electricity, and I get 35 litres an hour. So my 180 litre cylinder would take almost 6 hours to reheat once I'd run it cold. And obviously, if I put larger elements in, I heat more water, but I use a greater proportion of my available electricity. If we look at the bottom, 2 3 kilowatt elements, which is often what we specify into houses with numbers of bathrooms, particularly where the customers have had gas in previous houses and they're wanting to switch to an electrical system for sustainability reasons. We like to steer them towards more element power, but I'm now getting on for using up half of my available 65 amps. So I may need to start thinking about upgrading my electrical supply. But if I put 2 3 kilowatt elements into a 300 litre cylinder, it's going to take about 3 hours to reheat. Because the heat rises, we'll have some hot water available quicker than that because there will be hot water in the top of the tank. But to completely recover the tank can take a long time. For larger houses, and we see some beautiful architecturally designed homes that have features such as lifts and all sorts of other pools, pool pumps, large spa pools. They may have 3-phase electricity available on site. In that case, we can look at commercial water heater, which has 3 elements in it. We can go up to 3 5.5 kilowatt elements, and that'll recover a 300 litre cylinder in not much more than an hour. So there are options available to get more hot water, but it's obviously costly to do so, mostly in terms of the line charge that the power company might expect us to pay. Perhaps not so much today, but in the future. But for large homes, multi-element cylinders, if they've got three-phase power, are a good option. If we turn now to electric heat pumps, when we're thinking about sizing, we are looking at electric heat pumps in a similar manner to an electric storage water heater. So we're showing here the Rinnai Hydroheat, our New Zealand-made product, made here in our factory in Auckland, and we have the Rinnai EnviroFlow that comes from one of our international suppliers. It's similar to an electric tank when we're specifying. We really want to know how many people will be using hot water or showering within a peak period. In a heat pump, because of the way it's designed, and we won't go into that today, it stores a little less energy inside it for a couple of reasons. And so we should assume that maybe 80% of its stored volume will be emptied from the cylinder before it runs lukewarm, rather than 90% that we might get from electric storage cylinder. The other thing is a heat pump, generally a domestic one, will only heat the water to 60 degrees. If we try and heat the water hotter than that, they become inefficient. So they're normally preset to heat water only to 60 degrees. So all in all, for a heat pump, we're going to need one slightly bigger than an electric tank in order to do the same job. And we need to look carefully at the specifications of the product to make sure we're getting one that's going to meet the requirements of our clients. But generally, they need to be a little bigger. The heat recovery rate is similar to a 3 kilowatt element. It might be using a third of the electricity of the standard electric water heater, but it has no greater power input for a standard domestic product. That heat input will be greater when the air temperature is nice and hot outside, and it'll be a little less if the air is cold. If you're somewhere very cold, it can be a lot less. And they're usually configured so that they have electric elements inside them, so that if it becomes very cold and the heat pump is operating very poorly, that the electric elements will turn on and be used as well as or instead of the heat pump. So if we look now at gas continuous flow sizing, we have our standard gas continuous flow water heater. The labels on the front of the water heaters are at a 25-degree rise. So if we have a look at this one, and what we do to get the actual rate that we're going to get out the tap is we take that badged rate, we multiply it by 25, and we divide it by our actual rise. So in this case, again, we might be in Wellington. We've got a 30-degree temperature rise from the cold water to the temperature that we'll be showering at. Our water heater is a Rinnai Infinity EF26. The EF indicates it's the high efficiency condensing model. It'll use a bit less gas. So it's a 26 litre a minute at a 25 rise. So 26 litres a minute times 25 divided by 30. That water heater in Wellington in the middle of winter will put out 22 litres a minute. So we wouldn't get quite 3 8-litre a minute showers out of that water heater, but we would get two good showers from that water heater. In Auckland, where the water's 15 degrees more or less in the middle of winter, we'd get the full badged rate, the 26 litres a minute, so we would get 3 showers. In Queenstown, we'd get less. So this is a number we need to be really mindful of when we are specifying gas continuous flow water heaters, where you are in the country, so what the water temperature coming in to the product will be in the middle of winter. So the key specifying information for the gas continuous flow or an electric continuous flow, remembering that the key information for the storage cylinder was how many people, the key information for the gas continuous flow is how many outlets do you want to turn on at the same time. We don't care how many people there are because the water heater will run forever, but it's how many outlets you have on. If you open more outlets than what the water heater is specified for, the water temperature will remain stable, but the flow rate through each outlet will reduce. So we look at your plans, we count up the number of outlets, and we want to ask the client, do they really want all 6 showers in their house to run at the same time, or do they want the system size to run 4 out of the 6 showers at the same time? And we want to know the flow rate from each outlet. So we want to know if it's a real economizer shower at sort of 6.5 litres a minute, or is it might be a Hansgrohe rain dump shower operating at 10 or 11 litres a minute. So the two things we want to know is how many outlets simultaneously and how quick the water is coming out of each of those outlets. And if we know that, it's pretty simple to select and size a gas continuous flow water heater. Electric continuous flow. So electric continuous flow, same principle. We heat the water as we go. There are challenges with these. These products are really only for single bathroom, sort of affordable apartments or hotel rooms where the building has 3-phase power. Once you get into mid-rise buildings, they often have lifts, so there's often 3-phase power available. The electrical system needs to be sized to use these water heaters. They're very compact and they can be placed almost anywhere in the back of a cupboard. So they're a good solution, but they are really only for these applications. Why is that? If we look at our standard shower in Auckland, so somewhere relatively warm, 8 litres a minute raised 25 degrees, that will use 14 kilowatts of energy. Obviously, if we're in Wellington, if we're in Queenstown, because we're heating the colder water, it will take more than 14 kilowatts to provide for that shower. 14 kilowatts divided by 230 volts is 61 amps. Remembering that our standard house has 65 amps, you can see immediately that we are going to struggle for electricity supply. So we could have one shower only, and the lights might just stay on, LED lights, but if somebody cooked a slice of toast, the breaker would trip because we'd be drawing too much current. So we really don't use these in standalone houses. We don't use them for large homes because we would need one unit for each shower. And so that would quickly overwhelm even a 3-phase power supply into a larger home. You need to look out for models of these types of water heater that have fully modulating water flow controls. So similar to the Rinnai Infinity, this product, if the water flow becomes too high, it has got a valve inside it that will restrict the flow so that you'll always get the outlet temperature that you've set. Cheaper models, if you run not much water through them, you get the water temperature you want. If someone turns an additional tap on, you'll get lukewarm water throughout the system. So you really want to make sure those, if you're specifying these for mid-rise projects, that you've got one that is controlling the water flow properly. These water heaters have got lots of elements packed into a small space. The construction of the element is quite different to that in an electric storage water heater, and there's electricity in contact with the water. Don't stress about that, it's quite safe. But the water needs to have a composition between certain limits. If the water is too clean, its resistivity or its conductivity doesn't fall within a certain range, the product won't work. So we just need to be mindful if we're outside metropolitan areas, if somebody's wanting to use one of these, that we've checked their water quality or composition very carefully. So this is the Rinnai Efinity product that we'll be launching shortly on the market. They've just arrived. There's an 18 kilowatt that will do one shower in Auckland, or a 27 kilowatt that might do 2 showers in Auckland and Northland or 1 shower further south. So that's electric continuous flow. Same requirement for specifying as a gas continuous flow. We want to know how many outlets you want to run and what the flow rate of water out of those outlets are, bearing in mind that they're only ever going to run 1 or at most 2 outlets. So that's electric continuous flow. So we've sort of finished the looking at the water heaters themselves to a certain extent. This is a topic that we get lots of queries from architects on, particularly after requests for information from territorial authorities, from councils, after plans have been submitted. So H1, Building Code Clause H1, which is energy efficiency, there's a very small number of requirements in there for hot water systems. One of them in AS1, and it's the equivalent requirement in the other ASs for larger houses and buildings, is that water heaters less than 700 litres shall comply with New Zealand Standard 4305. So if we look in 4305, and yes, it was produced in 1996, you can't do a word search because it's sort of a scan of a typed document, I think. We come to clause 3.2.1, which limits how long the pipe can be between the water heater and the kitchen sink. And so it provides these limits shown in the red oval. And councils are constantly raising this with specifiers. And there are many things that councils do that I find objectionable, but I think that this particular clause, if you're not well within these requirements, your customer's going to get a pretty poor outcome. At my house, I wait 50 seconds for fully hot water at my kitchen sink. And had I paid someone to build a new house and I'd arrived and that's how it was, I would have considered that pretty unacceptable. These pipe lengths can add up pretty quickly because it's not, as you see on your plan drawings, a straight line. The pipe is normally running up from the water heater, might be running into the ceiling, it might be running under the floor, it's then running along to the outlet, up inside a wall and out to the mixer. So these lengths add up pretty quickly. So we really try and recommend getting the water heaters as close to the outlets as we can. And we really want to get the water heater close to the kitchen sink because the kitchen sink you generally use in short, quick bursts, and you don't want to wait for water to arrive. In a bathroom, particularly in a shower, you might turn the water on, you're going to be using the water for 10 minutes, and to wait 30 seconds for the water to arrive, you might not consider too bad. But your kitchen sink, you really want water to arrive quickly. So if we have a look at that in a little more detail, if I've got 9 meters of 20 mil or 19 mil pipe, it's going to take 26 seconds for fully heated water to arrive. 26 seconds doesn't sound like all that long, but if you're standing there trying to wash the gravy off your plate, 26 seconds seems to take forever. And you're obviously putting a whole lot of water down the sink and you're putting a whole lot of lukewarm water down the sink, and it can get pretty frustrating. So we really try and recommend architects and specifiers to keep the pipe runs to the kitchen sink as short as possible. So if we have a look at a set of plans that I lifted off the internet that didn't have a copyright notice against it, and we think about how we might specify the water heaters for this house. So we can see the cylinder is drawn in a cupboard next to the common bathroom. When I look at it, I think this building was nearly 20 metres long. I would say that that is going to be A, if the council spots it, they won't be approving the plans. And B, that's going to be an actual pretty bad outcome for the customer at their kitchen sink. So then we face this a lot with modern architecturally designed homes where the hot water outlets are quite spread out. So when we see a set of plans like this, the first thing that we generally try and do is we push to have an underbench cylinder next to the kitchen sink. Many of the larger homes you're doing now, of course, will have sculleries, and there'll be separate sinks in the sculleries, and the sculleries often provide a blind corner piece of bench that you can get a small cylinder into. I regard that installation, having just done the kitchen at my house, as being a free cylinder, because the highly expensive $1,800 or so kitchen corner unit that I shelled out for to use that space in the corner, I don't need that unit anymore, because I've used up that space gainfully with a small electric water heater that's going to give me near instant hot water at the tap. So I've spent some money on an extra water heater, and I've saved a whole lot of money on not having a blind corner shelving unit. So now we've dealt with the kitchen area of this particular house, we're going to have a look at what we could do down the other end of the house. So we've got a standard electric water heater sitting in that cupboard. That would provide pretty good service to both those bathrooms. What we do like to do is prioritise the master, the ensuite for the master. So we might think about shifting the water heater over to that cupboard. The person in that bedroom is obviously the one that's paying the mortgage, and let's give them a little bit more priority for hot water rather than the kids down the other end of the place that are using the common bathroom. If we want to save that space altogether and have a bigger bathroom, maybe we can eke out enough space for a walk-in wardrobe, and we want to shift our water heater outside, we could put an electric storage indoor-outdoor water heater outside there. Again, we've put that next to the master, and it would be a little bit of a delay, particularly to the vanity of the common bathroom. If the customer's looking at a heat pump, we'd be quite reluctant, I think, to put a heat pump out here. Heat pumps, obviously standard electric water heaters make almost no noise. A heat pump can be noisy. It might depend a little bit on where the bed was going to be located in the master bedroom, but we might be a little bit concerned about the noise of a heat pump water heater in that location. So we might think about, if it was a heat pump, shifting it over to the services side of the building. If we've got a customer that's thinking about gas, again, we could put a gas water heater over that side. Again, could be noisy. Might depend where the bed of in bedroom 2 was going to be located. We also have to be mindful of keeping the flue outlet of the water heater above that window in the bathroom. So we look at where else we might put a gas water heater. We could tuck one in this corner over the other side. That would be a pretty good place. We have accessories for our water heaters that allow us to make the flue outlet go sideways, so it wouldn't be aiming either at the toilet window or in the door of the garage. Lots of other options that we could consider if we go for an internal gas water heater. Internal gas water heater is a little more expensive. We have to flue the water heaters, and we know how much architects often love us putting penetrations through their beautiful roof lines. But if we were happy to flue vertically, we could put one in the top of that cupboard where the water heater was going to go. They're much smaller and would occupy only a fraction of the space and free up a lot of space for something else to go and where that cylinder was going to be. We could tuck one in the corner of the garage. We could put one in the laundry area. We could tuck one in that cupboard there. Again, a little bit noisy, but we've got a cupboard separating it from either of the bedrooms. Or we could go in the attic space above the hallway. So we've got lots of options that we consider for each set of plans. Some of the questions that we ask ourselves when we're going through what water heater we might select for a customer. We've covered close to the kitchen sink. Can we get an electric underbench in? In some homes, that's not practical, particularly smaller houses. available bench space is really small. Can we use multiple water heaters? Can we use multiple outdoor water heaters? For larger homes, we often look at ring mains. Now, ring mains is a whole subject all to itself, and we have a webinar coming up in the next few weeks that we're going to tell you everything you ever needed to know about ring mains, but we're afraid to ask. It's a really good solution for larger homes, but there are some things that you need to keep in mind when you're specifying them, and things that you need to work with your client and your plumber on. So we're going to do a webinar just on ring mains. Where are we going to put it? Are we going to be inside? Are we going to be outside? Are we going to go in the attic? What sort of flue are we going to use if it's a gas instantaneous? How much noise is it going to make, and how will that impact where we install it? So electric storage, no noise. Heat pump, we want to avoid bedrooms anywhere we're watching TV, as we do for a gas instantaneous. Access is a big thing. We don't want to have something that when it fails will be very difficult to get out. We've had houses where the roofs had to be removed in order to get water heaters out to be replaced. A water heater will fail one day. It doesn't really matter if it fails within a week because it was a manufacturing fault, of course, very unlikely with the Rinnai product, or it fails after 30 years. It's going to be just as big a problem to replace that water heater at that time. Electric storage water heaters, we have a series of drains coming from them. In order to make way for expanded water, they need to be pitched downwards. We need to be mindful of that. And we also need to be mindful where we put the water heater and when it leaks eventually, what that might damage. So we want to have a catch pan under that water heater if it's somewhere that's going to cause damage. And I think that's just about us. Over to you, I think, Alice.
Thank you very much for the information that you've provided, Grant. And now it's Q&A time. So here are some questions that we've received prior to the webinar. So perhaps we start with these. First question, Grant, what is the difference between Infinity EF26 and A26?
Okay, so I mentioned briefly the EF26. So the EF26 is a high efficiency product. It has a larger heat exchanger inside it, and it will operate at, depending on the model, somewhere north of 90% efficient. A standard product operates just above 80%. So it's going to use less gas. It's going to have less greenhouse gas emissions. In order to install one, you do need to provide a drain from the water heater to a sanitary waste point. That's not normally a problem. The water heater is normally in a service area where there are gully traps for outlets from the bathrooms anyway. But you just need to be mindful that you need to drain the condensate away from the EF models.
Sorry about that. So we've got another one from the Q&A section. Claire, what is the expected life expectancy of a hot water cylinder, and should it be replaced before it starts causing problems? The one she has is 180 litres mains pressure and was installed in 1994. It has performed perfectly with no problems and has been used all at that time. How can one tell when a new one is needed?
Okay, so it's hugely dependent on the water quality in your area. It's really difficult to tell when it's going to fail. Some will last an awful long time, some will fail very quickly. Inside it is a sacrificial anode, and it is possible to get those out and check that sacrificial anode and see how much of it is left. In practice, after 20 something years, that might be very difficult to do. We don't normally replace water heaters in New Zealand before they fail. In America, they often replace water heaters before they fail. When you move into a new house, it's common to get a new water heater. Theirs are generally not installed in cupboards with shelving around them as they are in New Zealand. So they're generally a lot cheaper to replace them over there. So unfortunately, the water heater will fail at the least convenient time. Of that, I can assure you. But it's really difficult to say when exactly it will fail by looking at it. The anode might give you an indication, but the plumber might really struggle to get it out after this period of time. I would say it won't be far off failure. 20 years or so is a pretty good run for a mains pressure electric water heater, but there's no way of telling. It might last another 10 years, it might last another 10 weeks.
Thanks for that, Grant. And another question from Tim. I have a client where, I have a client where the main pressure cylinder overflow relief valve constantly drips. Is this normal? Does it sound normal?
So about 20 years ago, in New Zealand, we changed from having we changed from having one pressure relief valve on a cylinder to having two pressure relief valves on a cylinder. So you need to have a look at your water heater and see if there seems to be one or two valves. If I flick back through the presentation to the Rinnai Ready Fit, it's going to take forever because of all my transitions. Must be getting close. No. I hadn't foreseen doing this when I thought I'd put all these transitions in the presentation. That one. Oh, a bit hard to see. So on the cylinder, there's a valve towards the top. It might be, in some models of water heater, it's right on the top of the cylinder. And then there's a second valve down here. It's hard to see in this picture. So that's the two valves. And you can see there's two bits of copper, one there going down the drain and a second one coming off the other valve down here. Now, if you've only got one valve, so it would be this valve at the top, and you would expect to see the drain line out of that dripping when the element is on and the water heater is heating. When the element turns off and the water is no longer expanding in the cylinder, this should stop dripping. If you've got both valves, this valve down the bottom should drip when the element's on and heating and not drip when the element is off, and the other valve should never drip. If you've got a constant dribble coming out of either of those valves, that valve needs to be replaced. You might try, there's a little lever on the top of the valves. You can lift the lever and see if you can clear away. There may be some debris that's sitting on the seat of that valve. So these valves are supposed to be opened and have some water flow through them. I think we say every 6 months. That's something you can do rather than your plumber. You lift that valve gently and you lower that lever again gently, and you might get lucky and wash out of the sealing part of the valve a little bit of debris that's causing that valve to drip. If that doesn't work, then you need to get your plumber to replace that valve because it's wasting water and wasting energy.
Next question, is underbench system efficient to run?
So if you have yes, they are efficient to run. They are, you're obviously not having a whole lot of losses from the pipe. So at my house, where I take 50 seconds to get hot water from my tap, obviously I run a lot of water away. I run a lot of lukewarm water away. When I turn the tap off, what I've done is I've filled up 9 meters of 20 mil copper pipe with beautiful toasty hot water that I've paid for. And then if I don't use that tap again for another hour, the energy that I paid for that went into that hot water in that pipe is now benefiting nobody but the spiders under my house that are sitting there nice and warm. So an underbench cylinder is absolutely a more efficient installation. It's also more efficient in a gas when it's combined with a gas water heater. Gas water heaters are really efficient when you do big long runs of hot water, like my son in the shower every morning. They're less efficient when you do lots of start-stop runs. They're still efficient, but they're less efficient. So a small electric water heater for short runs is a really efficient way of approaching the problem.
Thanks, Grant. I'm just bringing the next question up. So can HydroHeat be installed in solar-powered homes?
Okay, so there's a little bit of subtlety to this. You don't really want to install it on what I would think of as an off-grid home that has small battery capacity. Effectively, what we don't want is the HydroHeat starting and stopping a whole lot of time because it's run out of electricity. So if you're connected to the grid and you have solar panels on the roof, then it's absolutely a suitable product to have installed on your house. If you're on a small off-grid house with limited backup battery capacity, it's really not a suitable product because you will wear it out starting and stopping it too often. That's a small off-grid house. Obviously, we've supplied some water heating systems to Michael Fay on the Mercury Islands, and obviously while that is completely off-grid, it's a big enough system that it's the same as if it was connected to an electricity grid, so that's fine. But a house connected to the grid, absolutely. An off-grid house with limited battery capacity, then the answer is no.
Also, probably before the last question, if we can have the contact details of our specification team will come on screen very shortly. So last question is, how can you stop a thermally heated hot water system that has double valves and leaks? This has leaked from new and been changed. Is this because it is coastally heating, making it drip?
It'd be interesting to get through some images of that, and we'd be really happy to investigate that for you. That's not how we would normally expect a system to be operating. There could be a number of reasons for it, but it's absolutely not normal. So if you'd like to send us through your details, we'd be happy to have a look at that for you.
Oh, thank you. And just to answer your question, Brent, we do have another webinar coming up on the future of gas. I see your question on biogas. So we'll answer that in the next webinar. So also just to remind everyone to please contact us if you're interested, if you need to contact us for any more questions, and also our morning tea presentations or a quick catch up on product updates. Okay, so I will also post a survey link into the chat as well for today's webinar. Doing that as we speak. It would be greatly appreciated if we can please help by taking this 1-minute survey. And we're very keen to know the topics that you would like to hear from Rinnai and your feedback so we can make these webinars better for you. And as Grant has mentioned, the next webinar of the series will be on ring main systems on the 4th of July, where we'll be talking about the ins and outs about ring mains and most commonly asked questions. So thank you very much, everyone, for your attendance and participation today. Hopefully you now have a better understanding on the different water heating options for yourself and your client after today's webinar. So thank you again. See you next time. Mā te wā.